Good evening. My name is Ben Spanswick, and today we'll be presenting about workforce retention and attrition rates. So first, we're curious what causes attrition. Obviously, talent retention within a company is critical to have a successful business. It's a multi-billion-dollar industry, and given a data set, we're curious to see if we can determine what exactly causes attrition. Is it going to be typical factors at play? Pay, job satisfaction, job involvement, or is it going to be outside factors, relationship status, and amount of travel? First, a quick look at the data. It's a very rich data set that we were provided, almost 1,200 observations, 37 variables in total. Most importantly, though, as we can see to the right here, no missing data. This plot to the right shows 100% observed, which is great. No imputation is necessary. Looking at the data structure, it's pretty diverse. As expected, we're seeing a mix of continuous and categorical variables. Two here seem to have quite a few levels, over 3 levels. That's educational field and job role. We're going to come back to examine those in a little bit. It appears most of the numerical variables are actually categorical or discrete. You can see here by these single bars. As a result, that's actually as a result of the fact that most of this is survey data, so we know it's going to be a value between 1 and 5. This rand variable down here to the right, it seems to have perfect distribution, but we're not quite sure what it is. Eventually, we're going to exclude that from the data set. But among the other continuous variables, distribution seems relatively normal, nothing that raises anything of any particular concern. There are quite a few unnecessary variables. Employment count, always 1. Employment number is a random number. Everyone's over 18. Everyone seems to be working 80 hours. And then again, this rand variable down at the bottom. We're going to go ahead and just remove all of those variables right off the bat. Multicollinearity was a big problem in this data set. This plot to the right shows that. Especially down here, you can see the larger and darker the circle, the higher the collinearity between variables. That's certainly going to be an issue. A few of those which we noticed were years at the company is correlated with years of current manager, years since last promotion, years since current role. We got rid of those 3 and just kept years at the company. Income and seniority, job level, total working years, collinear with monthly income. And finally, performance and pay, percent salary hike, and performance rating are collinear. Nothing out of the ordinary, all sort to be expected, but it helps reduce the number of features in this data set by removing those. Here again, just a quick plot. You can still see there's a few few variables which are slightly collinear, but for the most part, we're pretty good. As mentioned earlier, we saw a few categorical variables with multiple levels. We're going to break those down a little bit further, specifically for job role, education field, and department. We ran a variance inflation factor test for these. Turns out, job role and educational field, you might expect to be collinear. Not actually the case. However, department is strongly collinear with other variables. As a result, we will be removing that. So very high-level variable selection, using GLM, Lasso, and R, we just quickly selected the top 20 most important variables. It appears right off the bat that the top 3 most important are job involvement, job role, specifically for research directors, and whether or not they're working overtime, specifically yes to overtime. So to answer that question, what causes attrition? The simple model is attrition is a combination of job role, job involvement, and job overtime. We also provided a K&N model, which can be seen in the code. We use a subset of numeric variables, and they were edited for correlation. And finally, we did create an advanced machine learning model. We were able to get area under the curve of 0.822, which is pretty great. You can see all the final feature set to the right, but we used an ensemble model of a number of different variables and did some bagging boosting, hyperparameter tuning. So where we go from here, we need to look at exactly which job creates high roles of attrition, how can we better retain employees, and